Alright, this is a practical on electricity, okay? So, but before I proceed what I have on the board, don't forget to subscribe before watching this video because I'll be dropping practicals as far as this current waec is concerned. So, this is setup diagram for this practical. This is the standard resistor that is given, which is 1 ohms, and this is the jockey. And this G is your what? The galvanometer, okay? This is the real star that is being given to us. And this is the constantant wire, okay? This is the key. And this is the cell, which is the what? The battery, okay? Okay, so from this point to this point is my meter watt rule, which is from 0 centimeter to what? 100 what? Centimeter, okay? So Ix is the distance from this point to this point. Yip is the distance from this point to this what point. Okay, so with the setup diagram, I can be able to what carry out this experiment. These are the procedures. These are the procedures involving what carrying out this practical on what electricity. And this is the table. This is the table for the what experiment. Okay. So with this setup diagram, I can be able to what carry out this practical. Okay, with me, I have this is the key. Okay, this is my what? My cell. This is my rheostat. Okay, this is my meter watt rule, and this is my jockey. This is the galvanometer. Okay, and this is the standard resistor that is given on the question, which is 1 ohms. Okay, and this is my what? Meter bridge. Okay, I did not even say it. This is the meter. This is the meter bridge, which is calculated on what? Which is calculated with a meter watt rule on it. So this is my what? My meter bridge. And remember, in this practical, two constantant wire is given to us. The one with brace. This is the one with brace, and this is the one with what? With lead. Okay, so we have two constantant wire. So I'm going to start with the first one. All right, so like I've said earlier, I'm going to follow the procedure on the board to carry out this experiment. The first thing I need to do on this is that I'll connect my standard resistor to my meter bridge. Is that what I'm doing? I'll connect my standard resistor to my meter bridge. Okay, the two terminal points on the meter bridge. I'm connecting my standard resistor to it. Okay, after then my key will move straight to the meter bridge as well, the first terminal point on the meter bridge. Is that what I'm doing? As you can see, I'll now have to tighten it very well. So this next part of the key will go to the negative part of the cell, which is this. It will go to the negative part of the cell. Okay, it will go to the negative part of the cell, which I've done. Okay, so after that, the positive part of the cell will now go straight to the what? Rheostat. So this is the rheostat. The positive part of the cell now, that is from the rheostat, it will move straight to the what? Positive part of the cell, which I have done. Okay, so the next thing I'm going to do now is that the second part of the rheostat will move straight to the meter bridge. Okay, is that what I'm doing? Okay, so the next thing I'm going to do here is that I'll now get my constantant wire, which is the first one I'm going to use. It will go straight to the second terminal point on the what? Meter bridge. Okay, I'll now have to tighten it. Do you understand what I'm doing? Okay, the next thing is that I'll get my meter rule to measure the constantant wire to ensure that it is what? 100 centimeter, because the first one I'm going to use is 100 centimeter. So I'm going to ensure that it is 100 centimeter. Okay, so this is 100 centimeter. Okay, so this is 100 centimeter. I'm going to remove it and I'll fix it to the second part, second terminal point on the what? On the meter bridge. Okay, So look at it now. This is where I'll be adjusting the constatant wire from 100 to 90, from 90 to 80, from 80 to what? 70. So the next thing I'm going to do, I'll come on the galvanometer, okay? The positive part of the galvanometer will goes to the key, to the, not key, it goes to the jockey. It will goes to the jockey. Okay, I'll have to tighten it so that current can flow. And the negative part of the galvanometer will goes to the meter bridge. Is that what I'm doing? It will goes to the what? Meter what? Bridge. Okay. Okay, so I'm done with this experiment. So the next thing I'm going to do on this, when the key is open, there will be no flow of what? Currents. But when the key is closed, there will be what? Flow of current. And the major thing about this experiment is that if I'm done connecting, which I've done, as I'm done connecting, when I close the key, there will be deflection between the both sides on the galvanometer. If I place it here, there will be a deflection. If I place the jockey here, the jockey here, there will be a deflection. That is, if I place a jockey on this point, there will be a what? A deflection on the galvanometer. If I place a jockey on this point, there will also be a deflection, which means that my setup is what? Is perfect. Okay, so let's try it and see. I'm going to close the key. I'm going to close the key. Okay, so I'll ensure that my cell is touching very well. So I'm going to use my hand to hold it. Okay. Okay, so I'm going to check this side. Is there a deflection? Okay, it's correct. There's a deflection on the galvanometer. I also check this side. There is a what? A deflection on the galvanometer. So the experiment is correct. So the next thing I'm going to do is that I'll keep moving the jockey to get my what? IX and what? IP. Okay, so I'll start from this point. I'll be moving it until it's on 0. I'll be moving it, is going. I'll be moving it, okay, until the galvanometer rests on 0. Okay, it's on 0. It's on 0. I'll now check. I have my 33.5. So 33.5. That's what I have. I'll now remove the key. So my what? My IX is what? 33.5. So my IP will be what? 100 minus what? 33.5. I'll get my what? IP. The next thing I'm going to do is that I'm going to now reduce my constatant wire to 90. Okay, I'll now have to carry out reading as well. So remember that this is what? This is 33.5. Okay, am I communicating? So let's proceed. I'm going to reduce this to what? To 90. I'm going to reduce my constatant wire to 90 because the one I used was what? 100 centimeters. So I'm going to reduce it to 90. How will I get it? Carry out the measurement on it. So I'll reduce it to 90. Okay, this is 90. So I'll have to mark it. I'll come down here and I'll do what? And I'll tie it. Okay, I'll tie it and I'll now have to make a grip on it. So the same thing I need to do, I'll have to close the key as well. I have to close the key. Okay, I have to close the key. Before that, I'll ensure that there's a contact on the cell. I have to close the key. If I close the key, I'll still check whether there's a deflection. If not, I am wrong. I'll check this side. There's a deflection, as you can see on the galvanometer. I'll also check this side. There's a deflection on the galvanometer, so I'm correct. So I'll start looking for my what? IX and what? IP. So I'll start moving the jockey. 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 Okay, so I am there. So what I have is 36.3. So 36.3. I'll remove my key, okay, so that current will not flow. So here is 36.3. So I have my 36.3. Okay, so 100 minus 36.3. I'll have my what? My IP. Okay, so that's it. I'll continue doing it until I get my words, my last and final words reading that is being given based on the what? The procedure. So this is how the setup is being done. The next thing I'm going to do, I'll still have to remove this constant wire and use the one with what? Brace. Okay, when you do that, you now discover that you still have another what? Reading. That is how this experiment is being done. Okay, so just don't forget to what? Subscribe after watching this what? Video. Thank you. I remain my humble self, Mr. Brown. Okay.